Hello, welcome to another video with Physics Anchor. Today we'll still continue with solving past questions for those people that will be writing JAMB or UTME. And today we have just a question on the board, and this question falls under electricity. So let's begin. So let's look at the question critically. An electrical circuit is connected up as shown below. What is the value of the current through 1 ohm resistance? So in other words, they want us to find the current that will flow through this 1 ohm resistance. So before we can get the current that will flow through here, we need to actually break down our connection of the resistors that we have here. So let's look at those that are connected in series and the one that is connected in parallel. Of course, when you look at these 3 ohms with these 3 ohms, you can see that both of them are connected in series. So this is a series connection. These two are connected in series because the current that will flow through this one will be the current that will flow through this one. So I hope you can see that. And when you also come here also, you see that the current that will flow through these 3 is the one that will also flow through these 3. So these and these are in series. These and these are also in series. So we can first do that by saying that if we redraw, since it's a series connection, okay, so you can say the first R total 1, let me call it R total 1, will be in series. That's 3 plus 3, that will give us 6 ohms because it's series arrangement. This one also, R total 2, let me call it R total 2. These 3 and these 3 are also in a series. So that will also give me 3 plus 3, that will be what? 6 ohms. So series connection is always addition straight up. So we have this 6, we have this 6, and this one is still standing alone. So if you are to break down this circuit will have become something like this. Okay, it will have become something like this. Or let's just make it this way. Okay, this is what we have now. Okay, okay. The 1 ohm is still there, and then we have the voltage that is 12 volts. So this circuit will have come down to something like this. So you now have what? 6 ohms. You have 6 ohms, okay, and then you have 1 ohm here. So in other words, by the time you see it, it's just like current coming to this place. So when currents get to this node, okay, it divides to this direction and divides to this direction. In other words, different currents will flow through this connection and different currents will flow through this connection. And you know that it's only in parallel arrangement of resistors that we have different current flow. So it means that the addition of this and the addition of this, they will be in parallel to what? Each other. So that is why we have that what? Connection. So these two here connected to become this 6, these 2 here connected to become this 6. Why this junction still remains? So you can see it's just like I'm drawing. I get to this junction, this one branch into 6, okay, and this one also branch into what? 6. So that is exactly what we have. Now we can say that these two, they are in parallel connection. So let's combine them. So that would be R parallel now. Okay, R parallel will be, you remember that it's going to be R1, R2 over R1 plus R2. I did something like this in the last video I uploaded. So you can now have 6 times 6 over 6 plus 6. So that will give us 36 over 12, and that will give us 3. So the total resistance now in these 6 and 6 ohms will be what? 3 ohms. So let's draw it. If these two combine now, so how will the diagram look like? The diagram will become something like this. Now that these two have combined to become what? 3. Okay, so that will be 3 ohms. And after they have combined, here they continue to the what? 1 ohm resistor. Okay, the diagram will look like something like this. Okay, so you have your 12 volts. So this is what the diagram will become. Once these two combine, both of them, they are not going to be in series with this 1 ohm. Okay, these two combine. When they have combined, it means that this line will become one. Just imagine that you are joining this line together. It becomes just a line to 1 ohm. So it means that what 3 ohms and this what 1 ohm will definitely be in series. So of course the question has become solved in the sense that since these are in series together, in series connection of resistors, we know that what the same current will flow. So in other words, the same current that will flow through these 3 ohms is the same current that will flow through this what 1 ohm. So what just remains for us is just to find our R total, which will be the series connection of this. That will be 3 plus 1 equals to what? 4 ohms. So for us to now know the current that will flow, we remember our Ohm's law. So V equals to IR. So the current is what we want to find. That's what V over R. Okay. So the potential difference across, okay, from here to here is actually 12. And the resistance is the what? Total resistance, which is what? 4 that we have gotten here. So I will be what? 3 ampere. So this same 3 ampere is what will flow through these 3 ohms, through this 1 ohms. So we can say current 1 ohm, that is the current that will flow through 1 ohm now, is now 3 ampere. Why? Say what? Series connection. Okay, so this is what we have. So we can see that the breakdown is just for you to have a profound knowledge in your series connection and your what parallel connection. In as much you learn how to analyze that circuit like that, that you can connect those that are in series with those in series, those in parallel with those in parallel, and you break it down, then getting your answer will be very, very easy. So I hope you have learned another great past question today, and this is under electricity. So try to watch the video over and over again until you grab the knowledge in this video. Try to share out this video so that more students can also learn from what we have done today. And subscribe if you have not done that. Hit on the notification button so that you can always get informed anytime I drop a new video. So till next time I will be coming your way, I wish you all the best in your examination. Bye for now.